Good day, students. This is your Geometry EOC Review Part C, Dilations and Similar Triangles. So again, we are in reporting category 1 still for congruency, similarity, right triangles, and trigonometry. This part of the test is 40% of the question, 46% of the questions that you will see on your EOC. So about half of the questions will still come from this category. So we will be covering 4 different standards in today's review. The first one is GSRT 1.1, knowing the properties of dilations, given a center and scale factor. SRT 1.2 is given two figures using the definition of similarity in terms of similar transformations. SRT 1.3 is using the property of similar transformations to establish the AA criteria for two triangles to be similar. And the last one is SRT 2.5, using congruence and similarity criteria for triangles to solve problems and prove relationships. So let's look at the first standard, SRT 1.1. So SRT 1.1 really just goes over the basics of a dilation. So we know a dilation changes the size of any polygon through a transformation. And there's always a center of dilation and a scale factor that's involved. We know that the scale factor can be found by providing the image over the pre-image. And there are some properties of dilations here that you can review. So go ahead to your key concepts in your notebook, pause the video and take an opportunity to review those concepts. And then once you're done reviewing those concepts, you can move on to the practice problems in your notebook. Once you've completed the practice problems, you can come back, play the video, and review your responses. Okay, so let's look at number 1. It says the image shown will undergo a dilation centered at point B with a scale factor of 2. Which lines will not be changed by the transformation? So there's some key information here that's given to us. They give us that we have a scale factor of 2. We have the center of dilation at point B, and it says the lines will not be changed. So this important information right here is key because it says lines will not be changed. So if it says the lines will not be changed, that means it's going to have the same slope. So same slope from that line, and also the points will be on the same line, or the line will be unchanged. So it'll be an unchanged line with that point as the center of dilation for B. So let's just do some process of eliminations of things that just make absolutely no sense. If it's going to have the same slope from point B, so point B is here, and we're talking about a scale factor of 2, that means we're looking for lines that are going to be on this line AC. So I have AC here. So that obviously would have to be the answer. If we're looking at AE, AE makes no sense because AE does not have the same slope as the point that's on AC, so that makes no sense. BE intersects at point B, but doesn't have the same slope. CD is way over there somewhere, that doesn't make sense. And then DE, clearly we can see doesn't have the same slope as AC. So AC would have to be my answer. If I'm looking from A to C, A to B, my slope here, so we have 1, 2, 3, 4, and then 1, 2, 3, 4. And then I look at the slope from B to C, that's 1, 2, and 1, 2. I see that I have 4 here and 2 here. So that tells me that I have a scale factor of 2 if I'm going from A to B and B to C. So that proves that scale factor. I have the same slope from A to B and B to C, and it's an unchanged line. So AC would make the most sense because we have the 2 criteria that's needed. Number 2 says a line segment is dilated by a scale factor of 2, centered at a point not on the line segment. Which statement regarding the relationship between the given line segment and its image is true? So again, we are looking at the properties that are needed for a dilation of a line. It says scale factor of 2 and centered on a point not on the line segment. Point not on the line segment. So what is the criteria for a point for it to not be on the line segment? Well, I know first I have to have a parallel line. The lines have to be parallel right? And then it has to be 2 times the length. If the scale factor is 2, it has to be 2 times the length, and if the point is not on the line segment, that other line has to be parallel to it. So we can automatically do some eliminations. Well, the first one is not correct because it says perpendicular, and the second one is not correct, perpendicular. So that knocks those 2. We have to look at the last 2. So the third one says the line segments are parallel and the image is twice the length. So we got parallel and twice the length of the given segment. And then the last one says lines are parallel, but the image is 1/2 the length. We know it has to be a scale factor of 2, so it's going to have to be twice. So that means our answer is the third option here. All right, so let's look at the next standard, which is SRT 1.2. This standard talks about similarity transformation. So now we're moving from lines to actual figures. So again, similarity transformations means that we can take a figure and use some type of sequence of transformations to map that figure from one figure to the next. And when we're talking about similarity transformations, those not only include dilations, but they also include reflections, translations, and rotations. The reason being is, even though reflections, translations, and rotations are rigid transformations, they still produce the same figure. All right, so those 3 rigid transformations are included in the similarity transformations. And we know that once we have similar figures, the corresponding angles are congruent and the corresponding side lengths are proportional. So different from congruent figures produce congruent sides, similar figures produce proportional sides. So take a moment to review those key concepts, and then once you are ready, move on to the practice problems. Go ahead and pause the video and work them out yourselves. And when you are ready, come back to check your responses. All right, so let's look at number 1 for SRT 1.2. It says 2 angle measures are given for both triangles ABC and XYZ. And we want to use this information to show that these 2 triangles are in fact similar. So remember, this little sign right here means similar. All right, so if I recall, 2 triangles must be similar if 2 things are true. The corresponding angles are congruent and the side lengths are proportional. Well, here they're not giving us any side lengths, so we can't talk about sides. So that can automatically eliminate one of them because it says similarity without knowing. We can't. Well, this one talks about knowing the side ratios. We don't have any side ratios, so obviously that doesn't make any sense. All right, but we do have some angles, so that means that we can determine which angles are going to be congruent. Remember, we can write congruency statements by looking at the positions of the angles for both triangles ABC and XYZ. So I can know that angle A is congruent to angle X because it's in the first position. Angle B should be congruent to angle Y, and then angle C should be congruent to angle Z. So if I can show that these angles are in fact congruent to each other, then we can say that the 2 triangles are similar. Well, we are missing 2 angles B and X, and we can easily find that by using the interior angles theorem for a triangle. We know that all 3 of the angles in the triangle's sum is 180 degrees. So for this one, 35 plus 65, that gives me 100, and I take 180, subtract 100, and I get 80. So that means angle B is 80 degrees, and I do the same thing here. 80 plus 65, that gives me 145. 180 minus 145, that gives me 35. So I know X here is 35 degrees, and then we just match up. So angle A and angle X, are they both 35 degrees? Yes. Angle B and angle Y, are they both 80 degrees? Yes. Angle C and angle Z, are they both 65 degrees? Yes. So we can say for sure, yes, these 2 triangles are in fact similar because of the angle-angle similarity property, meaning that if I can only prove that 2 angles in the corresponding triangles are congruent, then that means that the 2 triangles are in fact similar. Here we went above and beyond and proved that all 3 were corresponding and congruent, so we have our answer for number 1. Number 2 says triangle ABC is defined in the coordinate plane by the points A, 1, 1, B, 3, 4, and C, 4, 2, as shown. Under which transformation will the image of triangle ABC be similar to the pre-image? Select all that apply. So right here we are looking for a similar transformation. Remember, similar transformations include translations, reflections, rotations, and translations, and dilations. I think I said something that was more than what was needed. So rotations, reflections, translations, and a dilation are all considered similar transformations. So all we're looking for is to make sure that our figure is undergoing some type of rigid transformation, or our figure is undergoing a sequence of transformations that includes a dilation that has a scale factor for both the x and y coordinate. So the first one looks here like a rotation around 180 degrees. Will that produce a similar figure? Of course, it will still be the same size and shape as the pre-image. The second one here looks like there's some type of transformation and a dilation or a scale factor applied only to the y coordinate. It's not applied to the x as well. So this one cannot be true because we don't have a dilation with a scale factor for both x and y. The third one says that we have some type of dilation here because I see a scale factor for both the x and y that are exactly the same. So we can say, yes, this one is a similar transformation. The fourth one here, again, we have some type of transformation going on. That's a translation. And I see that it's applied to the x and y coordinate. So I can say, yes, this is a similar transformation because we're using a rigid transformation of translations. The last one says here that we are using a scale factor that's different for the x and y because the x and y are undergoing two different types of transformations. For the scale factor, we cannot include this last one. So we have the first, the third, and the fourth one as our similar transformations. All right, let's look at our next standard, GSRT 1.3. This one deals with the angle-angle triangle similarity theorem, where if I can prove that two angles in the triangle are congruent, then I know that the two triangles are in fact similar, and that also applies with their side lengths. If the side lengths are proportional, then we know that those two are also congruent, similar as well. So take a moment, review that key concept, look at the practice problems, and come back and see how well you did on those two problems. All right, so number one says the figure shows that triangle ABC is similar to triangle DEF. What side lengths? What are the side lengths as indicated? What is the value of x? So remember, if I'm shown that these two triangles are in fact similar, then that means that their sides must be proportional. So I'm looking at these side lengths, and I can set up a proportional relationship. So I can say that FE, which is given to us, is over ED, and that's in triangle DEF. And then I can say that it's going to be proportional to CB over BA. These side lengths that I'm looking at are side lengths that are corresponding from one triangle to the next based on the position of the letters in both triangles. So now I can just plug in the values for those side lengths. So I have 5 over 7, which equals x over 21. And of course, we're going to crisscross applesauce. So when we do that, we have x equals 7x, and that's going to be equal to 105. When I divide both sides by 7, I get that x is equal to 15. And if we want to make sure, we can plug that in, and we have 5 over 7 equals 15 over 21. And remember, if I divide this by 3, 15 divided by 3 gives me 5, 21 divided by 3 gives me 7. So that means I can check my answer to make sure that this answer is also correct. So we have x as being 15. Number 2 says in the diagram below we have segment AB is parallel to segment DC, so AB is parallel to DC, and AE is parallel to CG. AE is parallel to CG. And then we have EB and AG are drawn in between. It says which statement is always true. So let's think about what we already know about similar figures. If I know that I have two triangles that are similar or congruent, then there's a couple things that need to take place. If they're congruent, that means all angles and sides are congruent, corresponding angles and sides are congruent. And if they're similar, all angles are congruent and all sides are proportional. But right now we have no side lengths, so we can just only look at the angles. Okay. So let's look at DEF and CBF. So let's draw C, where those are, DEF and CBF. Okay, so they're saying that these two should be congruent. Well, I have these two angles here. Let's do a different color. I have these two angles here that are congruent, so those are corresponding angles. I'm sorry, vertical angles right there. And then let's see, is there any other information that I can gather? Not really. I can say that these two angles right here are congruent to each other because of alternate interior angles. And these two angles right here are going to be congruent to each other because of alternate interior angles. But we don't know much about the sides, so can't really say that they're congruent, because congruent triangles means that I have to have some type of side indicated that it's congruent. So yeah, we can't say this one right here. So let's look at some other ones. Next one says we have triangle BAG, and BAE, these two right here. Okay, so again, let's look at what we got. Based on the information that I have, don't really have any information really as far as congruency is concerned. Remember, congruency, we have to have some angles and sides that are shown, and we don't really have anything that we can say. So yeah, we're not going to mark this one as a possible answer. All right, so let's look at the next one. So we have BAG and AEB. So that just looks like the same two triangles we just had. Yep, they're the same two triangles, BAG and A. Yep, and again, that makes no sense. We didn't find anything for that one. So obviously the last one has to be the one that is our answer, but let's just look at it just to be sure. So DEF, and then we have the bigger one, AEB. So let's look at what's common here. So obviously angle E has to be congruent to angle E because they both share angle E. And then we see that side BF and side AB are parallel. So that makes some angle relationships right there. D and A are corresponding, and we see that D and A here are in the same position. So that's cool. And then F and B are corresponding, and again, they're in the same position. And guess what? We got 3 angles in one triangle that are congruent and corresponding to 3 angles in the second triangle. So therefore, these triangles must be similar because we just proved at least 2 angles in both to be congruent and corresponding. So that means that this one right here is a true statement. All right, so we're looking at the last standard, which is SRT 2.5, also assessed with SRT 2.4. And these two standards deal primarily with the indirect measurement of triangles, two similar triangles, and we are looking at the proportionality between heights and distances. And we're also looking at the triangle proportionality theorem, which says if I have a side of one triangle parallel to the side of another triangle, then the sides are divided proportionally. So just take the opportunity to review these key concepts, and then once you finish reviewing, go ahead and try out the practice problems, and then come back and see if you are on the right track. All right, so let's look at number 1. So number 1 says, in the diagram of triangle ABC below, we have segment DE is parallel to segment AB, and we have CD as 15 and AD as 9 and AB as 40, and we want to find the length of DE. So we're looking for this length right here of DE. So we already noted that DE and AB are proportional. are parallel. So that means that the sides of the two triangles are proportional. The sides of these triangles are proportional. So that means that I can set up a proportionality relationship. I can say that DC and DE is equal to the ratio of AC and AB. So now I can just plug in those values. DC is 15. We have DE as X. We have AC as 24. And we have AB as 40. So you're probably saying, well, where did she get the 24 from for AC? Well, remember this whole segment added together for 9 and 15 gives me 24. So now we just crisscross applesauce. So when I do that, I have 24x, and that's equal to 600. We divide by 24, and we get x is equal to 25. So the length of DE is 25. Okay, so we have number 2, which says a billboard at ground level has a support length of 26 feet that extends from the top of the billboard to the ground, and it has a post that is 5 feet tall. So we have a 5-foot tall post here, and it's attached to the support, and it's 4 feet from where the base of the support is attached to the ground. So the base of the support is 4 feet. And then it says in the figure shown, the distance in feet from the base of the billboard to the base of the support is labeled by X. So we want to know what is the value of X. What is the distance from the base of the billboard to the base of the support of the label. So this is the distance that we are needing to find that I'm highlighting in yellow. So first we have to recognize that we have 2 triangles. We have the larger triangle, we'll call that triangle number 1, and the smaller triangle, triangle number 2. We have to notice that both of these triangles are right triangles. I can see that indicated here. And then there's some side lengths missing. So we can assume that all right triangles are similar because they share some proportionality with each other. So then I can say that I have the smaller triangle has 2 side lengths and the larger triangle only has 1. So I can use a proportionality relationship to set up some type of proportion to find x. But before I do that, I have to find this missing side for the smaller triangle. Well, since it's a right triangle, well, we know to find missing sides of right triangles, we use the Pythagorean theorem. So I have 2 legs, so 4 squared plus 5 squared, and I'm needing to find that hypotenuse. So I have 16 plus 25 equals c squared. That's 41 equals c squared. So that gives me the square root of 41. And that means c is approximately 6.4. Okay, when I take the square root of 41. So now that I have the third side, I can go ahead and set up a proportion of the side lengths that I need. So I have 26, which is the hypotenuse of the big triangle, and x, which is one of the legs. And of course, when I set up my proportion, I have to make sure I have the same corresponding sides. So we already found that the hypotenuse leg was 6.4, sorry, of the smaller triangle, and then the corresponding leg to x would be 4. So of course, we crisscross applesauce. So when I do that, I get 104 equals 6.4x. And of course, we're going to divide both sides by 6.4, which leaves me with x equaling 16.25 feet. So I know that the value of x is 16.25 feet, meaning that it is 16.25 feet from the base of the billboard to the support. All right, ladies and gentlemen, that is it for me. Your responsibility now is to go to quizzes and do today's practice for Part C of your Geometry EOC review. Do not forget about your IXL skills for this week and any makeup or redos that you need to turn in. Have a great day, guys. See you in class.